We start. This is a little pre-recorded video, so playing it. It's a bit longer than normal with a bit over 60 minutes. So that leaves a little bit of time for the session Q&A after, which means please fire away with your questions right away when they pop into your mind, so we can go straight through them once the video starts. For now, enjoy the video.
Hi, my name is Radu Craioveanu. I'm with Fresenius Medical Care, and I'm here to talk about how we've optimized FHIR to develop applications that work. I've been with Fresenius Medical Care for the past 11 years or so. I'm a VP of Software Development, and during my tenure there, I developed quite a large number of applications. Some are charting, point-of-care based applications. Some are patient management, full of workflow and interaction between groups. What we did to enable the build out of these portfolios is we put together a FHIR digital platform that supports smart on FHIR, security, caching, microservices-based integration, event-driven integration. And we're currently running about 40 million daily transactions through this FHIR infrastructure. We've also been doing a lot of IoT, as we have 55,000 or so dialysis machines in the field collecting data from our patients pretty much on a 24/7 basis. A little bit about Fresenius Medical Care. We are a worldwide organization. We are the largest dialysis healthcare provider in the world, and we're also the largest healthcare provider for dialysis in North America. I am part of the North American organization. And we have about 3,000 or so clinics that we operate in North America, ranging across 8 time zones from Puerto Rico to Hawaii. Our business model is, clearly dialysis. There are a couple of modalities. The most popular one is hemodialysis, where you sit next to a dialysis machine for about 3 hours a day, 3 times a week, and your blood gets filtered and cleaned outside of your body. There's also peritoneal dialysis, where you take treatments, 5 to 6 or sometimes every day. And that can be done at night. And instead of having the dialyzer in the machine outside of your body, you have the dialysate bags there inside your stomach cavity. Because of the long treatment times, there's a lot of data that gets produced during this, this course of treatment. I just want to point out that what's going to be important is that we are looking at about 20,000 staff operating concurrently on our patients. We have a total of 40,000 staff, and we deliver about 25 million treatments per year. Well, at Fresenius, we built a pretty significant FHIR infrastructure. We have built a series of internal applications. Most of them are smart on FHIR applications, whether they're EHR launch or standalone launch, and they're either charting applications at the point of care or patient management with workflow for interdisciplinary teams. We built a FHIR-based enablement layer, and I call it enablement layer because it connects to the lower system of record layer, which is made up of our EMRs, our laboratories, our pharmacies, SAP, our data warehousing, and so on. We've also built external applications, smart on FHIR. Some are built in the Salesforce Health Cloud, and some in Azure or AWS for various channels for our providers, patients, partners. In terms of internal integration, as well as external interoperability, we also use FHIR to a large extent. And in many cases, we convert from internal FHIR to external eHealth Exchange. What I want to talk to you about today is a couple of applications that we felt that we wanted to share because we discovered and we adapted FHIR to suit our needs and to scale to our needs at Fresenius. One of them is, so typically in our clinics, you have about, say, 100 to 200 patients being treated at the same time. And our clinicians would want to see a dashboard with all our patients together and all those insights on the dashboard. They want to know if something is happening with a patient. They want to know if some patient needs attention in real time, or if there's some workflow need and say today's schedule requires X, Y, and Z for that patient. In order for us to solve that, we ended up having to create a DB view. Think of materialized or even dynamic view from the relational database worlds, where you want to get to many resources, pull them together, and make them available to your application in a very optimized way, one indexed or a few indexed calls only. We ended up calling this strategy and implementation the App Accelerator. We've developed the App Accelerator with our partners from Smile CDR. There's James Agnew from the HAPI library folks. And on their website, they describe this App Accelerator as the need for an application to have dashboards with significant insights that are not just flat data, but sometimes calculated data. So they show here this dashboard where you have 5 vitals and a score. And instead of pulling data for each patient and calculating the score for each patient as you display it, the idea is that you can create some sort of composite resource in FHIR that contains all this data that's populated in real time and calculated at the time of change, and then the application just pulls the entire thing when it needs it. These are some of the more technical details and implementation entities used by Smile. We basically worked this together, designed this together to meet our needs, and it essentially has an aggregation component and a retrieval component. The aggregation uses filters and keepers to know which resource needs to be groomed, which resource needs to be aggregated, and then the retrieval is an optimized way of pulling that data. In our specific use case, we're going to use one of our applications that we use in the clinics to manage our vascular access. So as you can see here, you have, it looks almost like an Excel spreadsheet, but this is what our clinicians desire. You have the patient information on the left column, and then you have clinic, and then you have some calculated columns about exposure, when it was last used, baselining, which is some calculations, and then you have events, workflow events that are required for that particular patient and for that particular patient's condition. An additional requirement to our dashboards is that our clinicians want to be able to do real-time search, real-time sort across the entire population. So as you can see, all this data that is the subset data at the patient level also needs to be pulled up at the same time. Typically, in a clinic that is treating about 250 patients at the same time, a typical dashboard would end up doing about 1,200 FHIR calls per patient, and overall you'll be looking at about 1,500 FHIR calls per clinic dashboard with an average response time of 3.4 seconds per dashboard, up to 15 max. Many of these calls, believe it or not, are actually using comma separated, so but a lot of them cannot be done with comma separated, so that's why you have the math doesn't exactly look like it makes sense, but trust me, it does. Anyway, 1,500 FHIR calls per clinic dashboard is a lot of calls. The App Accelerator idea is based on what's called a Slivebundle. A Slivebundle is actually a custom code for composition, and it is made up of a rule. In this case, we're using a rule called urgent start PDC. And this rule indicates to the engine the data that needs to be pulled, composed, calculated, in each application or in the application that's using the rule. An important component of the Slivebundle is what's called the subscriber group. The subscriber group could be one patient, could be a clinic, could be any ad hoc collection of elements. In this case, we're showing that the subscriber group is a clinic, is an organization, and it's the patient and patients in that organization that will populate the dashboard. The Slivebundle supports include and include recurse, as well as sorting to further help out the application and the dashboard. When we look under the hood at the response body of a Slivebundle, it could be pretty large, but in general, we use gzip to retrieve that data to minimize the travel time of the data. But it's a bundle. It's a composition type of bundle. It has a list of patients. In this case, it has a list of patients. And this is just showing the first patient in the array and some of the reference data that the patient has. In our case, it would be body sites or the vascular access. You're also seeing the details of the body site itself. I think the important part here at the end is that once we apply the App Accelerator technology to this application, we go from 1,500 calls per clinic dashboard to about 12 bundle calls per clinic dashboard. And more importantly, we're reducing the CPU for our database by about 30%, and the I/O for the database has been reduced by 50%. And we see the average response time come down to under 1 second, and we're seeing a very deterministic max response time of 1 second. Moving on to the second type of example or use case that we want to explore is we have interdisciplinary teams that need to operate on workflows related to a patient. And what we want to share here with you is how we used the JBoss BPM and BRMS to help our FHIR applications accomplish that. FHIR and BPM go hand in hand. FHIR already anticipated workflow resources, and we're using the JBPM suite from Red Hat with the upstream community of knowledge is everything. If you look at the resources that FHIR has established for workflow, their task, requests, communications. In our case, what we're going to explore here is how we used FHIR and we used BPM to automate a formulary exceptions management process that we have. The formulary exceptions drugs are typically more expensive. They require extensive approval process, and our process used to be very manual. Paperwork being submitted, and an approval team being involved, and then the EMR being updated manually. And these are some of the examples of what would have required a formulary exception, anywhere from devices like dialyzers to medication. At a high level, what we're looking at is we have the user making a request for an exception. A task is created in FHIR. The BPM component subscribes to the task. The BPM then runs the rules. Now, these rules run in the background as well. That's why they did not dynamically apply, because we're running rules for patients as the patients get admitted to our clinics to establish their financial and eligibility. Financial and clinical eligibility. Once the rules are run, a task gets updated, and then the application subscribes to the task. The EMR gets updated with an assessment that shows that the user has been enrolled or accepted, and then the user of the application gets the approval or the denial message. As far as the FHIR data model that we're using and the resources that are being used, if you look from right to left, we're looking at questionnaires, questionnaire responses, where we walk the user of the application through the questions that are required to be asked. We capture that in a communication. and the communication has a device request or a medication request, and it's all managed by the task. In terms of the BRMS model, what you're looking at here is that this set of rules gets exercised constantly in an automatic fashion or upon user demand. We run the common rules first and then the specific rules to medication or device. The only one thing that I want to point out here that's more interesting is that we run the denial rules, not the approval rules. You'll find that every time you run a BRMS and a set of rules, you want to run denial rules because it's easier. Because as long as one of the denial rules succeeds, your whole process can move forward. Unlike if one of the approval rules succeeds, you have to wait for all the rules to complete, and at that point, it doesn't really matter. And it's also much more difficult to to manage approval rules rather than denial rules. If we look under the hood, the task is the key element that's being used to communicate to the BPM and to the application, and the task is what we're using from the task is the input, and we have in the string we have a JSON parse that we're going to pass down to the BPM with all the commands. We could have used there some BPM-Input or CQL. We chose to use our own JSON, and then BPM comes back with an output value in the task, and in this case, for instance, you can see that the request has been denied, and you have the reason for denial. Essentially, what we found is that once we implemented the BPM and this entire automation for this very manual process, we ended up saving about 100 to 200 person hours per day, and we essentially recovered the cost of the project in 2 to 3 months. Yes, there were some challenges. BPM and BRMS are not simple. It takes a while to understand and to learn the dialect, but it's definitely worth investing the time. Here's a list of resources that you might refer to if you want to understand better how to use BPM and BRMS with FHIR. Now, I'll just conclude with this, right? We've shown here two problems that we solved with FHIR and with some innovations on top of FHIR additionally. We've committed the organization to using FHIR for not only interoperability but also application development, and we continue to believe strongly in FHIR and its ability to help us as a healthcare enterprise. I will stop right now and I'm going to take questions. Thank you very much. Here's how you can reach me. I'm on LinkedIn. You can use my work email, and I'd be more than happy to talk to you guys about what we've learned and how things were. Thank you very much.
All right. Thank you very much for the video. There are two questions. First, maybe you can elaborate a bit on, or not elaborate, it's the wrong word. Can you maybe give some lessons learned from how you handled the project, so mistakes are not necessarily made again?
Sure, yes. One of the first mistakes we ran into is that our developers started using FHIR as if they were on top of a database. So when you're on top of the database and say use Hibernate, it's very chatty. You don't have to worry so much about context. But once you use an API like FHIR, it can get really chatty, and FHIR is pretty chatty itself. It has a lot of data. So that was one of the things that we learned, and it took us some time to learn. And that's where we had to innovate and create these different surfaces that are more optimized for our applications to use.
All right, great. Another question, could Slivebundle also have been implemented with the query construct in the FHIR search?
Yes, probably. I think there are many ways that you can implement the Slivebundle. What we wanted to do is leverage a series of of components that are already part of the FHIR standard, which is subscription, composition, and some of the search capabilities. It was important to us to remove the joins. So a FHIR search is excellent, but when it's complete, it has so many joins. We wanted to bring everything into a single index to lookup kind of thing to take the pressure off the database. So we built up this composition with references. So the composition is one lookup, the reference is a direct lookup, minimal number of joins, relieved a lot of pressure on the database and improved performance.
All right, thanks. We're just going to do one more question. We actually ran out of time, but I think 1 minute extra is not that bad. How do you manage FHIR resources across various care locations within your organization? Context being the ordering location and the fulfilling location could be different. How is the metadata managed for multi-location scenarios?
So actually, what we've chosen to do, and we might rejigger that a little bit, but currently we have one FHIR surface. So we have a set of FHIR servers, about 20, 30 FHIR servers living on top of Oracle Exadata database. And that FHIR surface is used by everybody. We don't have bounded context for different FHIR business operations at this point. So it's a centralized FHIR server approach rather than distributed.
All right, great. Thanks for the answer. We did run out of time. There are new questions coming in. So yeah, please keep asking questions. That's no problem. You probably have some time to answer them after the session has concluded. But for now, thank you very much for your video and for the answers to the questions. And hope you enjoyed the rest of DevDays.
Thank you very much, everybody.